activity to demonstrate ignition temperature of materials. Make two paper cups by folding a sheet of paper. Fill 50 milliliter of water in one of the cups. Now heat both the cups separately with a candle. After some time, you will observe that the empty paper cup burns quickly while the paper cup containing water does not burn. But it becomes hot because the water in the cup absorbs the heat and distributes it to all the parts that holds water. So, in the presence of water, the paper does not attain its ignition temperature. Hence, it does not burn.
Introduction. Observe the flame of the LPG and the candle. Can you see that the flame of the LPG is clean blue in color and does not leave any other gases? On the other hand, the candle burns with a yellow luminous flame, leaving behind black soot or residue. In combustion, the substances that vaporize produce a flame. When a candle is lit, the molten wax rises through the wick and gets vaporized to produce a flame. A fuel like charcoal does not vaporize and so does not produce a flame. Structure of flame. Observe the flame of the candle. We can notice that the flame of the candle has three regions: innermost zone, middle zone, and outer zone. The innermost zone has dark black vapors of wax. In this part, the vapors are not burnt and therefore it is the least hot region of the candle. In the middle zone, the wax vapors start burning. The color of the flame is yellow. Since oxygen available in this region is not sufficient for the wax vapors to burn completely, and therefore the temperature in the zone is not very hot. In the outer zone, the wax vapors burn completely in the presence of sufficient oxygen from air. The color of the flame is blue and the temperature in this region is very high. Innermost zone. Let us do an activity to show that innermost zone of a flame consists of unburnt wax vapors. Take a candle and place it on a table. Now light it with the help of a matchstick. Bring a glass tube and introduce one end of the glass tube in the innermost zone of the flame. Now bring an ignited matchstick near the other end of the glass tube. What do you see? We see a flame at the end of the glass tube. The innermost zone of the flame near the heated wick consists of unburnt vapors. These wax vapors enter the glass tube and come out from the other end. And on introducing a lighted matchstick near the end of the glass tube, the wax vapors coming out of it catch fire, producing a flame. So we can say that the innermost zone of a candle consists of unburnt wax vapors. Middle zone. Let us perform an activity to show that the luminous or middle zone of the flame consists of unburnt carbon particles. Take a lighted candle and place it on a table. Introduce a glass slide into the luminous zone of the flame with a pair of tongs. Hold the slide for about 10 seconds. Now remove the slide from the flame and observe. A circular blackish ring is formed on the glass slide. So we can say that the luminous flame consists of unburnt carbon particles. Outermost zone. Finally, let us do an activity to show that non-luminous zone is the hottest part of the flame. We have a lighted candle placed on the table. Now, hold a thin, long copper wire just inside the flame with a pair of tongs for about 30 seconds. Observe carefully. The part of the copper wire just outside the flame turns red hot. This is the non-luminous flame of the candle. It has a high temperature and is the hottest part of the flame. Summary. A flame
of a person catch fire. The person is covered with a blanket to extinguish the fire. Can you guess why? The blanket is so thick that it stops the supply of oxygen or air to the burning person and the fire is extinguished immediately. That is why burning person is covered with a blanket to extinguish fire. The lowest temperature
History of matchstick. A matchstick is used to light candles, gas stoves, oil lamps, etc. Do you know that the first matches were developed by the Egyptians more than 500,000 years ago? These matches were made of small pieces of pine wood dipped in sulfur, which is a combustible substance. The modern safety match was developed about 200 years ago. It was made by applying a mixture of antimony trisulfide, potassium chloride, white phosphorus, some glue, and starch on the head of the match, made of suitable wood. When this stick was struck against a rough surface, white phosphorus got ignited due to the heat of friction. This started the combustion of the matchstick. But white phosphorus proved to be dangerous both for the workers involved in manufacturing of matches and for the users. Hence, nowadays, the head of the safety match contains only antimony trisulfide and potassium chloride, while the rubbing surface has powdered glass and a little red phosphorus, which is much less dangerous than white phosphorus. Some red phosphorus gets converted into white phosphorus when the match is struck against the rubbing surface. The white phosphorus immediately reacts with potassium chloride in the matchstick head to produce heat required to ignite antimony trisulfide and start the combustion. Thus, we have learnt about the history of a matchstick.